Hello everyone, hope you all are doing well. So in this video, we'll discuss the second problem of Leetcode Weekly Contest 324. It's a medium level problem, but relatively better than the other second level problems that you get. You can see that with the accuracy as well. So we have 14,000 submissions, but only you can see just less than 6,000 have been accepted. So the accuracy is pretty low. Let's see what the problem is asking us to do. So the problem name is smallest value after replacing with sum of prime factors. The problem name is pretty big. So you are given a positive integer n. Okay, continuously replace n with the sum of its prime factors. Now note that if a prime factor divides n multiple times, it should be included in the sum as many times as it divides n. Okay, return the smallest value n will take on, right? Let's see what it says. So here initially our n is 5. Okay, so what are the prime factors of 15? Sorry, n is 15. What are the prime factors of 15? So it is 3 and 5. So what do? You replace 15 with the sum of its prime factors. So the new n will be 8. Okay, now what are the prime factors of 8? It's 2, 2, 2, right? Remember, 2 is dividing 8 multiple times, right? Just assume that. What do you need to do? You need to check that 2 8 can be represented by this, right? Or I can say 2 into 2 into 2. So consider 2 3 times only, right? Basically factorize it and sum all the values. So here 2 into 2 into 2, so add 2 plus 2 plus 2, the new n becomes 6. Now what about 6? 6 can be written in form of 2 into 3, so the new n will become 5. 2 plus 3, 5. Now you can see 5 is the smallest value n will ever take on, right? Because how can you write 5? It can be written as 1 into 5. Now it is already a prime number, right? You cannot reduce it, so that's why. Now comes the question. Now n equals to 3, so again it's already a prime number, so you cannot reduce it. So that means 3 will be the smallest value our n can take, right? So yeah, this is my solution, but to be very honest, I don't think there is any particular logic that we need to discuss in this problem. But okay, more of an implementation type question. Whatever the problem is asking you to do, you do that stuff, right? So let me walk you through the solution, and then we'll go into the depth of why this implementation works and why another implementation doesn't work. Okay, so this is our function. Okay, this is our function. We have a value n. Now just see what I've done. I have called a function generate primes. Why I have done this? This is my small function. Why I've done this, right? Because you just see the value of n goes to 10 raised to power 5, right? So one of the approaches can be that for every n, right, you run a loop. So suppose you want to find the prime factors of a number. What you do? You start from 1, you go to 2, 3, dot 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 till n. 1 is this option. The time complexity will be big O of n, right? What could be the other? What could be the other option? Then another option could be 1, 2, and then n by 2. This is also big O of n. What is the third option? 1, 2, dot 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 square root of n. So this is square root of n, right? So just see here, these things will time out, right? These things will time out because suppose you are given a number which is which is reducing, and the number of iterations that you have to do is pretty large. So every time if you run a loop of big O of n, so that can time out, right? And that is not the most optimal solution as well, right? So what do we need to do? Instead of calculating the prime numbers every time, right, you calculate it once, you save it. What are the prime numbers? Because we need to find the sum of the prime factors, so calculate the prime numbers. So how do you calculate the prime numbers? So I have taken a list here. Right now there can be many ways of calculating the prime numbers, and while calculating the prime numbers you can use any of them, right? You can use any of them, but the crux is calculate the prime numbers beforehand so that you do not need to calculate every time. So what I've done, in my list I've added 2 because 2 is a prime number, and then I've checked every number 3, 5, 7, 9 whether or not this number is prime, and then if it is a prime number I've added it into my list. Now why I have skipped 4, 6 and 8? Because obviously every multiple of 2 is not a prime number, right? Only if 2 is a prime number, all the multiples of 2 cannot be prime, so that is why. Now you can use this, or what you can do, you can use sieve of Eratosthenes. So there are multiple ways of calculating it, but again this is one of the way. Now see, this function is prime. How do I check whether a number is prime or not? So just see what I have done. I have done this. If n is less than equal to 1, return false. if n is less than equal to 3, return true. Why? Because if I have 1, so this will return false. If I have 2 and 3, it will return true, right? What about this logic, right? So what happens if you are familiar with certain patterns, right? Again, what I'm saying, calculate, checking whether a number is prime or not is up to you. This is one of the ways that I'm telling you, right? There can be multiple ways. Okay, so what you can do is, if you see the patterns of prime, right? So 5 is prime, then 7 is prime, right? Then 11 is prime, then 13 is prime. Okay, right? Then what do you call it, 19 is prime, and so on. So you just see this number is actually 6 into n minus 1, this number is 6 into n plus 1, this number is again 6 into n plus 1, and so on. So this is also one of the ways of finding whether a number is prime or not, right? So that is the approach that I've used here, right? So if a number is divisible by this, then it's not a prime. So the first thing that I've done is, if n mod 2 equals 0, or n mod 3 equals 0, what I mean to say is, remember 2 and 3 are prime for me. If a number is divided by 2 or 3, that is not a prime. Simple stuff. Now what do you do? For I equals to 5, again the square root logic, and I square is less than equal to n, I plus equals to 6. Why I plus equals to 6? Because let's take an example. Suppose you are on 11. You know 11 is not prime, or 11 is prime, right? Now 12 cannot be prime, because this is 6 into n minus 1. This is 6 into n. That means it is divisible by 6, right? Now what do? You again check for 13, right? You again check for 13. So this is 6n plus 1. This is 6n plus 2, 6n plus 3, and so on. So if I represent 6 numbers, it can be represented by 6n, 6n plus 1, 6n plus 2, plus 3, plus 4, plus 5. So just see, this cannot be a prime number because it is divisible by 6. This cannot be a prime number, it is divisible by 2. This cannot be a prime number, it is divisible by 3. This cannot be a prime number because it is divisible by, again, 2. And what about this? What about this? This can be a prime number. So if you write 6n plus 5, or you write 6n minus 1, that is the same thing, right? That is the same thing. So that is why you just need to check for these numbers, 6n plus 1, or, right? So what I mean to say, just jump 6 at a time and you will be done, right? You will be done, because 6n plus 1, 6n plus 1, and then you move to 6n plus 5, and so on. So that's the same thing that I've done here. You start from I equals to 5, I less than equal. Now you are checking for all the numbers, that whether they are dividing n or not. So now I plus equals to 6. So just see what I'm doing. Is I able to divide n? If yes, return false. Or if n divide I plus 2, right? So again, the same logic that I was telling you. Again, it can vary for person to person, right? If these two, if any of them satisfy, you return false, or return true. So this was about how to find whether a number is prime or not. So the crux is generate all the prime numbers. Now what do you do? Previous equals to n. You start with n, and while true, you keep on getting the sum, right? You keep on getting the sum. How do you get the sum? Simple. Just see, I have a list of prime numbers, so I keep on checking if n divides current and n is greater than 1. So simple, you keep on adding it, divide n, right? This is very basic stuff, so not we don't need to go into details of it, but yeah, these are some of the things that I've done. Now once you get the current sum, you check it with the previous sum. If both of them are equal, that means my number cannot be reduced. You just break it and return previous, or else update your previous with the current sum that you have received, and keep on doing this, right? Keep on doing this. Now just see, why I've added a while loop here is because in case of 8, I can divide it by 2, I get 4. Now again I can divide it by 2. So this 2 is used multiple times. So that is why it's a while loop and not a if condition, right? So yeah, that's it for this problem. I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case of any queries, do let me know. I'll be more than happy to revert on each one of them. Thank you. Take care. Bye bye.